On Friday, we started this lesson called Solving Quadratic Equations by using the quadratic formula. We reminded ourselves that if a question were to ask to solve or find the roots of a parabola, so solving a quadratic equation means to solve for the independent variable, the x variable. And specifically, if they ask us to find the roots or zeros, which means the x-intercepts, we must first set f at x or y equal to 0. So we looked at two scenarios. The first scenario was here, this is our original equation, find the x-intercepts or zeros. So we subbed in y equals 0 first, and then we were able to factor. Two numbers that multiply to -8 and add to -2 are -4 and 2. And we were able to solve for x. So in this case, our zeros would be x1 would be 4, and our x2 would be -2. When we do the same for the bottom here, we run into a problem. So we plugged in y is equal to 0 here, but then we were stuck because there was no two numbers that multiplied to -9 and added to 2. So we couldn't factor, can't factor, which means that we can't solve this any further. So actually there is a way to solve this. There is a couple ways to solve this without factoring. So if we are stuck and we cannot factor, another method that we could solve for x with is called using the quadratic formula. So the quadratic formula is derived by something called completing the square, which we'll be looking at in the next unit. But it's this big complicated equation right here. So we practiced by using these two examples below. So I'm just going to do one of the examples again. If you really do understand this, feel free to move ahead to the next examples that we haven't done. So inside the quadratic formula, we have our x, that's what we're looking for. Then we have b's, a's, and c's. The a, b's, and c's come from the coefficient of each term when it's in standard form. So standard form means we have the squared term first, then the degree 1 term, and then the constant term. So in this case, our a is equal to 2, our b is equal to 6, and our c is equal to -3. So we have a is right here, b is right here, and c is right there. So once you have your a, b's, and c's, all you're doing is you're plugging it in to the equation. So we have x equals, take a look at the equation again, and we've got -b. So that means I have to copy the negative and then plug in b. So I have negative, and b is 6. Then we have a plus or minus square root of b squared, which is 6 squared, minus 4, our a is 2, and our c is -3. And divided by 2 and times a is 2. So I'm really just plugging in the formula, plugging in our a, b's, and c's into the formula here. Okay, so next I highly recommend that you just put what's under the square root sign into the calculator. So you copy absolutely everything else and just put what's under the square root sign into the calculator. So we'd have x is equal to -6 plus or minus square root of 60. So that 60 came from taking 6 squared minus 4 times 2 times -3. So using BEDMAS, exponents, multiply, and then subtract, you're going to get 60. And all divided by 2 times 2, which is 4. So we have two cases here because we have this plus or minus sign. So the first case is if we take the plus, and the second case is if we take the minus. So our two cases come from x1 being -6. And we'll say plus root 60 all over 4. And our second case is going to be -6 minus root 60 all over 4. So if we plug both into our calculator, just remember that there's implied brackets here. So if we've got addition or subtraction happening on the top of or bottom of a fraction, that means we've got to deal with this addition or subtraction first and then divide that by 4. So I'm going to put -6 plus root 60 in brackets and then divided by 4. Same with over here. So if you plug that into the calculator, your first x value should be 0.44 and your second x value should be -3.44. So quickly sketching, we went over this on Friday. This makes sense because this parabola because our a is equal to 2, which is a positive number, this problem is going to open up. So it might look something like this. And so what we're doing here is we're solving for when y is equal to 0, what is our x, or in this case our t? Well, we're getting two answers, and two answers make sense, because that means that this must have two different zeros. So here's our first x-intercept, and here's our second x-intercept, which is why we are getting two different numbers here. So it's okay in a quadratic equation to, when we plug in a y value, that we get two different x values, because we know it's symmetrical. So we did the next question together as well. If you haven't done it, try it on your own and check your answers against somebody else. The next question says that a digital sensor is recording the height of a baseball after it's hit into the air. Quadratic regression on the data gives the quadratic relation, blah, blah, blah. How long is the ball in the air? Okay, so let's draw a quick sketch before we get started. So we know that we can only have positive xy axis here. Now what this question is missing, it says that it gives that f of x is the height of the baseball, but it doesn't tell us what x is. So that means that let's just add it in here. It was missing from the question. X is the length of time in seconds. Okay, so that was just missing from the question, so let's add it in there. X is the length of time in seconds. So we have x at the bottom, which is really our t, our time, and we have height as our y value, which we know is really just f of x. So this guy here is just f of x. Okay, so if the baseball's hit in the air, it's going to look something like this. It's not going to start at the ground, but it's definitely going to end at the ground. So the question is saying, how long is the ball in the air? Okay. So at what point do we stop recording the ball in the air? Well, it starts in the air at point 0 when the time is equal to 0, and it stops being in the air when it hits the ground. So what we're really looking for is we're looking for this point here when it hits the ground. And we aren't given any information about it, except we actually know that the height at this point has to equal 0. If the ball's on the ground, it means the height is equal to 0. Also, if we drag it across here, we know h is equal to 0. So in this case, this means that our f of x is equal to 0. So let's plug that into our equation. So right now our equation was f of x equals negative 4.9 x squared plus 20.58 x plus 0.491. And now let's sub in that x is equal to 0. So we will have 0 equals negative 4.9 x squared plus 20.58 x plus 0.491. So now we have an option here. Do we want to factor this, or do we want to use the quadratic formula? Factoring this would be very, very difficult because we have decimals. I don't want to look for two numbers that multiply to negative 4.9 times 0.491 and add to 20.58. It would be much faster in this case to use the quadratic formula. So flip over to the quadratic formula in the previous page, and let's fill in our a, our b, and our c. So in this case, our a is going to equal whatever the coefficient of x squared is. That's negative 4.9. Here's our b, and here's our c. So on the side, I'm going to write our a is equal to negative 4.9. Our b is equal to 20.58. And our c is equal to 0.491. Plug it into our equation. So we've got x is equal to negative b, so we have negative 20.58 plus or minus the square root of b squared, which is 20.58 all squared, minus 4, a is negative 4.9, and c is 0.491. All divided by 2 times a is negative 4.9. So again, I'm going to first put everything under the square root into my calculator. So I will have x is equal to negative 20.58 plus or minus the square root of 433, and let's say 0.14, we'll take 2 decimal places, all over negative 9.8. So here are our two options here. We have negative 20.58 plus the square root or minus the square root. So our first option is negative 20.58 plus the square root, 433.14, all divided by negative 9.8. And the second option, x2, is negative 20.58 minus the square root of 433.14, all divided by negative 9.8. So let's see what these two come out to. So x1 comes out to negative 0.02 seconds approximately, and our x2 equals approximately 4.22 seconds. So we have two different options for x. We have negative 0.2 seconds and we have 4.22 seconds. So let's go back to our graph to see which one makes sense here. So we have a positive 4.22 and a negative 0.02. So we know time can't be negative, so this doesn't make sense. The reason why it's coming out is because we know theoretically this parabola is going to have a 0 right here. That's going to be a negative number, but in this case it doesn't make sense in this real life problem of a baseball player hitting a baseball because it doesn't exist in this negative time. And so the ball is going to be in the air from 0 all the way to this point here, which is 4.22. So that is after 4.22 seconds. So this is the answer that makes sense, and this one does, and this one over here doesn't. So we can finally conclude that therefore the ball will be in the air for 4.22 seconds. Let's go on and do the next example.